Let knowledge flow like a river, without any hindrance. Don't make it like a stagnant pool. Hey Excel wizards! I'm PS Chatterjee, and welcome back to my channel. Today, we're diving deep into some powerful Excel functions: ABS, SQRT, round, ceiling, floor, fact, and RAND. Remember that time you struggled with a complex calculation? Well, these functions can simplify your life and save you countless hours. By the end of this video, you'll be a master of these functions and how to use them to solve real-world problems. To demonstrate these functions, we've created a dynamic dashboard using drop-down menus, data validation, VLOOKUP, and conditional formatting. Except for conditional formatting, we've covered these techniques in previous videos. I'll be creating a dedicated video on conditional formatting soon, so stay tuned. Whether you're a student, a professional, or just curious about Excel's capabilities, this video is for you. So, fasten your seatbelts and get ready to level up your Excel skills. Let's start with the RAND function. And remember, if you find these tips helpful, don't forget to like, share, and subscribe for more Excel tips and tricks. Hit that notification bell to stay updated on my latest videos. Let's dive in. Excel function RAND. Now, by the help of drop-down menu, I am going to select random number. And you are watching a very simple syntax equals RAND and empty first bracket. Let's explore the fun and versatility of this function today. Next, we'll input this formula into cell A4. As you can see, Excel immediately displays a random number less than 1. This function generates random numbers between 0 and 1. To populate other cells with random numbers, we'll simply copy and paste the formula from cell A4. Each cell will now display a unique random number. Where can we use this powerful function? Simulations and modeling. Create realistic scenarios and analyze potential outcomes. Gaming and entertainment. Generate random events, character attributes, or game outcomes. Data science and statistics. Sample data, test hypotheses, and simulate real-world phenomena. Cryptography. Generate random keys and encryption algorithms. Testing and validation. Create random test cases to assess software quality. Machine learning. Train models on random data subsets. Decision making. Simulate random choices and their consequences. Recreational mathematics and hobbies. Solve puzzles, play games, and explore mathematical concepts. With RAND, the possibilities are endless. So, let's continue exploring its applications and have some fun with Excel. Alright, our next function is RAND between. Excel function RAND between. Next, let's switch gears and explore the RAND between function. This function allows us to generate random integers within a specific range. You'll see that I've changed the drop-down menu selection to random between. The syntax for this function is, equals RAND between and within first bracket, x_1, x_2. Here, x_1 is the lower limit, and x_2 is the upper limit of the range. Let's input the formula equals RAND between, within first bracket, 1, 5, into cell A4. As you can see, Excel displays a random integer between 1 and 5. To populate other cells with random numbers within this range, we'll simply copy and paste the formula. Each cell will now display a unique random integer between 1 and 5. Where can we use this powerful function? The use cases are similar to the RAND function. Now, let's explore our next Excel functions, round, roundup and rounddown. To do that, I'll scroll down to the bottom of this sheet. Excel function round. Next, we'll dive into the world of rounding with the round, roundup, and rounddown functions. These functions allow us to round numbers to a specific number of decimal places. Let's start with round. The syntax for this function is equals round, within first bracket, number, or the cell reference, comma, x. Here, number or the cell reference is the value you want to round, and x specifies the number of decimal places, which can be 0 or any integer. In cell D8, we have the number 7.125963324. If we input the formula equals round, D8, 3, into cell L8, we'll round the number to 3 decimal places, resulting in 7.126. Our next Excel function is roundup. Excel function roundup. Now, let's explore roundup. This function rounds a number up to a specific number of decimal places. The syntax is similar to round, equals roundup, within first bracket, number, or the cell reference, comma, x. Using the same example, if we input equals roundup, D8, 3, into cell L8, we'll get 7.126. Our next Excel function, rounddown. Excel function rounddown. Finally, rounddown rounds a number down to a specific number of decimal places. The syntax is equals rounddown, within first bracket, number, or the cell reference, comma, x. If we input equals rounddown, D8, 3, into cell L8, we'll get 7.125. Where can we use these functions? Financial calculations, rounding currency values to the nearest cent or dollar. Data analysis, rounding numerical data for better readability and interpretation. Engineering and scientific calculations, rounding measurements and calculations to a specific precision. General data cleaning and formatting, ensuring consistency and clarity in data. Now, let's move on to the ceiling function. Excel function ceiling. Next, let's dive into the ceiling function. As the name suggests, this function ceiling rounds a number up to the nearest multiple of a specified significance. Can have different behaviors depending on the sign of the number and significance. The syntax for the ceiling function is equals ceiling within first bracket, number or cell reference, comma, significance. Here, number is the value you want to round up and the significance argument in the ceiling function determines the multiple to which the number is rounded up. It must be a positive number to ensure that the function rounds up to a larger integer. Unlike the round, roundup, and rounddown functions, which round to a specific number of decimal places, ceiling rounds to a specific multiple. Let's look at an example. In cell D8, we have the number 7.125963324. If we input the formula equals ceiling within first bracket, D8, 1, into cell L8, we'll round the number up to the nearest integer, which is 8. Now, let's change the significance to 2, equals ceiling within first bracket, D8, 2. Since 8 is the nearest multiple of 2 greater than 7.125963324, the result will still be 8. If we change the significance to 3, equals ceiling within first bracket, D8, 3, the nearest multiple of 3 greater than 7.125963324 is 9, so the result will be 9. Now let's move to Excel function CEILING.PRECISE. Excel function CEILING.PRECISE. Next, let's dive into the CEILING.PRECISE function. CEILING.PRECISE always rounds a number up to the nearest multiple of a specified significance, regardless of the signs. Uses the absolute value of the significance. The syntax for the CEILING.PRECISE function is, equals CEILING.PRECISE within first bracket, number or cell reference, significance. Here, number is the value you want to round up and the significance argument in the CEILING.PRECISE function determines the multiple to which the number is rounded up. Significance value may be a positive or negative integer, but CEILING.PRECISE function will consider the absolute value of that integer to ensure that the function rounds up the number to a larger integer. Unlike the ceiling functions, which rounds a number up to the nearest multiple of a specified significance, can have different behaviors depending on the sign of the number and significance. Let's look at an example. In cell D8, we have the number 7.125963324. If we input the formula equals CEILING.PRECISE within first bracket, D8, 1, into cell L8, we'll round the number up to the nearest integer, which is 8. Now, let's change the significance to 2, equals CEILING.PRECISE within first bracket, D8, 2. Since 8 is the nearest multiple of 2 greater than 7.125963324, the result will still be 8. If we change the significance to 3, the nearest multiple of 3 greater than 7.125963324 is 9, so the result will be 9. Now if we change the significance value from 3 to -3, the nearest multiple result will be 9. It shows that the function CEILING.PRECISE ignores the sign of the significance value. Where can we use the ceiling and CEILING.PRECISE functions? Financial calculations, rounding up prices to the nearest dollar or cent. Inventory management, rounding up quantities to the nearest whole unit. Scheduling and planning, rounding up time durations to the nearest hour or half hour. By understanding the ceiling function, you can effectively round numbers up to specific increments, making your calculations more precise and efficient. Now let's move to Excel functions floor. Excel function floor. Next, let's explore the floor function. This function rounds a number down to the nearest multiple of a specified significance. The syntax for the floor function is, equals floor within first bracket, number or cell reference, significance. Here, number is the value you want to round up, and significance determines the multiple to which the number is rounded. The significance must be a positive number. To illustrate, let's consider the number 7.125963324 in cell D8. If we use the formula equals floor within first bracket, cell D8, 1, it rounds down to the nearest value less than 7.125963324 and which is divisible by 1, and it is 7. Now I am changing the value of significance from 1 to 1.333, and we are watching the value changed from 7 to 6.665. 6.665 is less than 7.12596,324, and if we divide 6.665 by 1.333, result will be 5. That means 6.665 is divisible by 1.333. Now if we change the significance value from 1.333 to -2, there will be no result, and we are watching #NUM. It shows that the function ceiling only accepts the positive numbers as a significance value. Now, let's delve into the FLOOR.PRECISE function. Excel function FLOOR.PRECISE. Next, let's explore the FLOOR.PRECISE function. This function rounds a number down to the nearest multiple of a specified significance. The syntax for the FLOOR.PRECISE function is, equals FLOOR.PRECISE within first bracket, number or cell reference, comma, significance. This function is similar to the FLOOR function when significance is a positive number. Here, number is the value you want to round down, and significance determines the multiple to which the number is rounded. Unlike the FLOOR function, the significance value in the FLOOR.PRECISE function can be either positive or negative. However, the function will always consider the absolute value of the significance. To illustrate, let's consider the number 7.12596,324 in cell A8. If we use the formula equals FLOOR.PRECISE within first bracket, cell D8, comma, 1, it rounds down to the nearest value less than 7.12596,324 and divisible by 1, which is 7. Now, if we change the significance to -1, the function will still consider the absolute value, which is 1. So, the result will remain 7. Next, we will delve into the ABS or absolute function. Excel function ABS. Next, let's dive into the ABS function, short for absolute. As the name suggests, this function converts a negative number into its positive equivalent. The syntax for the ABS function is, equals ABS, within bracket, number, or cell reference. For example, if we have -6.125 in cell D8, using the formula equals ABS, within bracket, D8, will give us 6.125. The ABS function is incredibly useful in various scenarios, such as financial calculations, calculating absolute differences between values, like profit and loss. Data cleaning, removing negative signs before further analysis. Statistical analysis, calculating absolute deviations or errors. Mathematical operations, ensuring positive values for operations like square roots and logarithms. Now, let's explore the factorial function. Excel function fact. Now, let's explore the fact function. This function calculates the factorial of a number, which is the product of all positive integers less than or equal to that number. For example, the factorial of 7 is calculated as 7 into 6 into 5 into 4 into 3 into 2 into 1 equals 5040. The syntax for the fact function is, equals fact within first bracket, number or cell reference. To illustrate, if cell D8 contains the number 6, the formula equals fact within first bracket, cell D8, will return 720. It's important to note that the fact function only works with integer values. Any decimal part of a number will be truncated. So, if you input 6.999, the function will still calculate the factorial of 6. To illustrate, now if we change the value in cell D8 from 6 to 6.999, the factorial value will remain same, and it is 720. Factorials have many applications in mathematics and statistics, such as in permutations, combinations, and probability calculations. Practical example, say we have 7 different colored balls. We want to know how many different ways we can arrange these balls in a line. First position, we can choose any of the 7 colors. Second position, after choosing the first color, we have 6 colors left. Third position, after choosing the first 2 colors, we have 5 colors left. Fourth position, after choosing the first 3 colors, we have 4 colors left. Fifth position, after choosing the first 4 colors, we have 3 colors left. Sixth position, after choosing the first 5 colors, we have 2 colors left. Seventh position, the last color is automatically placed. So, the total number of arrangements is factorial 7 equals 5040. Next, we will delve into the SQRT function. Excel function SQRT. Now, let's explore the SQRT function, which stands for square root. This function calculates the square root of a non-negative number. The syntax for the SQRT function is equals SQRT, within first bracket, number, or cell reference. For example, if cell D8 contains the number 16, the formula equals SQRT, within first bracket, cell D8. Will return 4. The SQRT function has many practical applications, including geometry, calculating the hypotenuse of a right-angled triangle using the Pythagorean theorem. Physics, solving equations involving distance, velocity, and acceleration. Statistics, calculating standard deviation and other statistical measures. Engineering, designing structures and systems. By understanding and utilizing the SQRT function, you can solve a wide range of mathematical and scientific problems. Next, we will delve into the practical application of SQRT function. Practical application of SQRT or square root function. Now, from the drop-down menu, I am changing the context from square root to quadratic equation and square root. In this portion of the dashboard, you are observing a quadratic equation, ax squared plus bx plus c equals 0. Here, a and b are the coefficients of x, while c is a constant. You can also see the Sridhar Acharya's formula, x equals minus b plus minus square root of b square minus 4ac by 2a. This formula is displayed in this highlighted cell. Beside it, you can see the values a, b, and c along with green blank cells. These blank cells are for entering the values of a, b, and c to calculate the values of x. In this cell I have typed equals, minus b, plus square root of, b square, minus 4ac, by, 2a, and in this cell I have typed equals, minus b, minus square root of, b square, minus 4ac, by, 2a, to get the two values of x. That formula you are watching below this cells. On the right corner of this row, you can see the expression for b square minus 4ac displayed. When you input the values of a, b, and c, the program checks the discriminant b square minus 4ac. If b square minus 4ac less than or equal to 0, the result will display not applicable. This is because, when any of a, b, or c equals 0, the value of x becomes undefined. If b square minus 4ac less than 0, the formula involves an imaginary number, which is beyond the scope of real number solutions. Let's test with some examples. First trial, input values, a equals 0, b equals 0, c equals 0. Result, no output is generated. Second trial, input values, a equals 1, b equals 1, c equals 0. Result, x1 equals 0, x2 equals minus 1. Third trial, input values, a equals 1, b equals 1, c equals 1. Result, no output is generated as the discriminant, b square, minus 4ac, is negative. Fourth trial, input values, a equals 1, b equals 3, c equals 1. Result, x1 equals minus 0.382, x2 equals minus 2.618. Finally, we see that for the quadratic equation to have real number solutions, the discriminant, b square, minus 4ac, must always be greater than 0. This practical application of the SQRT function in Excel demonstrates how mathematical concepts can be implemented efficiently. That's a wrap on today's Excel adventure. We've delved into the world of functions like ABS, SQRT, round, ceiling, floor, fact, and RAND. With these tools in your Excel arsenal, you can tackle complex calculations with ease and precision. Remember, the best way to master these functions is by practicing. So, roll up your sleeves and experiment with different scenarios. If you found this video helpful, please show your support by liking, sharing, and subscribing. Your feedback is invaluable, so feel free to leave a comment below with any questions or suggestions. Together, let's unlock the full potential of Excel. Thanks for watching.